Okay, I don't know if you can tell, but I got a new little holder, I guess, stand for my iPad. So I think this is going to work out a little bit better, but it is going to have this weird shadow here. And I've been playing around with the light for a while. I just can't get that to go away, but I'm hoping that the improvement in my handwriting will be worth dealing with that shadow. So now we're going to talk about neutralization reactions. And that should not be an unfamiliar term to you, because we did learn about them way back in Unit 4 when we first learned about acids and bases, okay? So a very, very long time ago, we learned that when a strong acid reacts with a strong base, they are always going to form the same kind of products. And one of those products will always be water, or H2O. And we're going to see an example of that down here, a couple different ones. I don't know if you remember what the other product is other than water, but it's actually a salt. And remember that when we say a salt, we mean something that is ionically held together, not necessarily NaCl. It could be KCl or barium bromide or something like that. All of those things are salts. And because the acid and the base react together to form water, these are often called neutralization reactions. Because I know that we haven't gone into acids and bases very in depth. That's actually the next unit that we're doing. But I think you know enough to know, just from everyday life, that water is neutral. So that's kind of where the neutralization comes from. And it's called a neutralization reaction because exactly the right amount of acid reacted with just the right amount of base to become neutralized, okay? And my rule for this is that you always need to write out the net ionic equation of what's going on. You're going to see why that's important, but it is absolutely, absolutely essential, okay? So it says in this example, what volume of 0.100 molar HCl solution is needed to neutralize 25 milliliters of 0.350 molar sodium hydroxide? Okay, now what did I just say is the first thing you need to write out? The net ionic equation. We're doing a reaction here. We're taking HCl, we're reacting it with NaOH, and we need to put those things together. So if I have HCl, and we'll be good students and write out the states, reacts with NaOH, we've got to think about what the products are going to be. So this is where you got to think back to that Unit 4. This right here is going to end up being a double displacement reaction, which means that my H is going to end up with my OH, which will give me HOH, or more commonly written as H2O, right? And then my Na will end up with my Cl, and I'll have actual table salt as my salt. It's kind of the classic acid-base reaction. But if you'll remember, not all of these things are a part of the net ionic equation. Back in the day, we had to write 3 different ones: the MIE, the CIE, and the NIE, okay? I can go ahead and write out the CIE. I feel like at this point, a lot of you guys could skip it, but we'll do it just as a review. Okay, so I've got this right here. Then we go through and we look for those things called spectator ions, the things that aren't a part of the reaction. My H2O is a liquid, so that's the only thing that doesn't get broken up. And the only things that don't change from the left side to the right side are my sodium ions and my chlorine ions. So the only things that are left are my H pluses and my OH minuses coming together to form my water. Now, that should seem very, very familiar to you because back in Unit 4 when we did acids and bases, we learned that the net ionic equation for every strong acid, strong base reaction was going to be this in some way. You're always going to have H pluses and OH minuses coming together to form water.